So this is supposed to be the beginner React meetup, right? Can I get like a show of hands of what that means to you? Like, you know, because beginner React is, you know, it's very vague, right? Let's say if you're just looking to get into programming, you know, is there anybody here that's trying to get into programming? Okay, we got a couple. All right. Maybe like a year of JavaScript or less. Okay. Maybe a year of React or less. Okay. Anybody that has more than a year of React? Okay. All right. That's good to know. That kind of gives me an idea of where we're at. My presentation actually doesn't have a ton to do with React. It obviously is related to React. React follows some, you know, programming paradigms, but at the same time, we're not going to be going through like do's or don'ts of React or anything like that. I'm just going to share some things that I have found useful as I've tried to figure out what in the world people are talking about as a beginner when it comes to programming paradigms, because it is really frustrating to sit there and read a paragraph about React or something and it says, you know, that this is functional or this is declarative or whatever, and it seems like everybody kind of has a different definition of it also. So like I remember going to like trying to figure out what something meant, and I looked on the Microsoft website. I found something that described one of the programming paradigms, and then I went to, I think maybe a Facebook or Google page, and it seemed like they were completely opposite of what they were, you know, they were using the word totally differently. So the title of my talk is Funclarative-Oriented Impercedural Programming. Yeah. This is just a bunch of different programming paradigms mashed together. Functional, declarative, object-oriented, imperative, procedural. Yeah, there's some other. We're going to talk about those different paradigms. I have to say this. Like, who was just talking? What was his name? Ryan. He, at the beginning, he threw out kind of a disclaimer, like, these are my opinions, right? Like, I don't know. That's the same way I'm looking at this. This is my paradigm. This is what has been really helpful for me to understand these different definitions and how they interact with these paradigms, interact with each other. But you're going to go out on the internet and you're going to see different opinions about what these mean and what they mean to each other also. I would suggest doing some research and come up with your own definitions. And then as time goes on, you'll see somebody say, you know, use that word a little differently, and you can say, well, this is the way I understood it. Why is that different? How does it fit into my understanding of things? Okay, first I want to talk about the abstract and the concrete. Abstract and concrete, very often, before you get into the programming world, it kind of means simple and complex. I don't know why. That's the understanding I kind of had of it for a while. Abstract and concrete in programming does not mean simple and complex. And it doesn't mean that anywhere else, too. What the real meaning of concrete is real. Concrete means something real. Abstract means something not real. Okay? That doesn't mean that abstract things aren't real, but when you compare them to something concrete, they are not real compared to the concrete thing. They're often used relatively to compare things. So in reality, the way I look at it is when I say something's concrete, what I'm actually saying is that it's more concrete than something else. Sometimes you can just say something is absolutely concrete and it's fine, but often they're comparing it, and sometimes implicitly, sometimes explicitly. Sometimes they actually say what they're comparing it to, sometimes it's just implied. So more real and more not real, or less real, I guess that's probably a better way to say it. Okay, so concrete versus abstract. We just learned about it. So this is for audience participation. One is more concrete, one is more abstract. One is more real, one is less real. The idea, concept of a fox versus an actual fox. Which one's which?
The concept is abstract, and the actual fox is concrete.
Yep, pretty simple. The idea, concept of a fox versus the word fox.
Word is abstract.
The word is, in my opinion, the word is more abstract. It actually describes the concept of a fox, right? And if you disagree with me, that's fine. A picture of a fox versus an actual fox. Say it louder, I'm not hearing.
Picture of a fox is abstract and the actual fox is concrete.
Okay. And a picture of a fox versus the idea, concept of a fox.
Picture of a fox concrete.
Picture of the fox, concrete idea. Okay, I would actually probably argue the opposite of that. The picture of the fox is actually what is describing maybe the idea or concept of a fox. Like when you look at it, but this is kind of where I'm going. It's like, what's the right answer? I don't know. Sometimes it's a little tricky. What about like a picture of a fox versus the word fox? Like, can you compare those? I don't know that you can. I don't know that you can say one is more abstract than the other, or one is more concrete than the other. What about calling your girlfriend a fox? Concrete, abstract? Is this like maybe a higher order?
That's concrete.
I guess it depends on your girlfriend. You might end up in Let's see.
Since she was a fox.
What is the most concrete way to program modern computers? Does anybody know the answer to this? The most real way.
Assembly code.
What's that?
Assembly.
Assembly, you're getting darn close.
Machine language.
Machine code, machine language. Okay? So machine code is the actual like bits, the zeros and ones. Now they're not represented as zeros and ones here. This is hex. But this represents what is it? 32 bit. The 2 hex. I don't know. These represent zeros and ones, and each one of those zeros and ones corresponds to an action, right? So this one is, I don't know what it does. Location of string into dx. I don't know how they got that from that, but I do know this right here, the string hello world. This is a hello world app, by the way. There's a lot of different machine codes also. Sometimes this would work, sometimes this wouldn't work, but this is an example. So the 48 right there is the hexadecimal equivalent of the ASCII T, right? Capital T, I believe. So that actually says hello world. This is the most concrete way to program a modern computer. I say modern computer meaning like, you know, the old way might be punch cards or something. So if you get down to it, it's the same thing. It's a bunch of bits that are programming a computer. So what is the first abstraction away from this base level of programming? Assembly, right? Okay, so here is an example of assembly. And these comments might make a little more sense now because I've included the assembly. So location of string into dx. If you look here, you can see this 0, 1 and the 0c. It's the same thing over here. The BA, I don't know, this move dx is probably what this BA is. Does anybody read machine code?
It's good.
Did somebody raise their hand?
It's been a while.
It's been a while? Okay. I should have you guys.
There's basically like a manual that comes from Intel that has like these correspond to these other, they're called opcodes, which are
Yeah.
the instructions.
Yeah, so these are opcodes right here, right? And these would probably be opcodes, like this first column. And these are like the payload going with those opcodes. I don't know how it works, but you can see here it's an abstraction, right? It's a little easier to read this. Why would anybody do this? I mean, the machine code worked just fine, right?
Because
Why
it's
would
so
Can't
like,
read the machine code.
Much easier.
Okay. Right? So what's the purpose of abstracting something in programming language?
so allow you to not have to worry about the implementation details.
Okay, that's a good thing. Did anybody else have another? Faster. It's faster.
Simplifying it.
Simplifying it. Okay. Did somebody? Yeah,
It's easier to figure out what's going on.
easier to read and understand. Yeah, I like all those examples. Abstractification, right? I don't think that's a word. Might be. I don't think it is though, because I looked it up and some sites had it, but I think they were saying that it wasn't a real word. Yeah, abstraction maybe. So abstractification. This first abstraction off of machine code is assembly. Are there further? Can we abstract on an abstraction?
Yeah.
Yes.
Okay, well, give me some examples of this.
It's got C, got
C,
Java.
Java, that's way up there, right?
I can't remember the other ones. Yeah,
Pascal?
Pretty much any language that you
Yeah, so every language is an abstraction,
Yeah.
right? I mean,
The further up you go, JavaScript sits on C++ to do the things that we do with JavaScript.
yeah, Node is C++ language. But C++ itself is an abstraction of C. Like it takes C and then it adds this object-oriented component to it. Okay, so this is just a side note to help us talk a little further about this. The computer is to machine code as the browser is to what? JavaScript, right? JavaScript. So we start extracting and abstracting away from machine code in the browser. We're doing the same thing. Like the most concrete way to program in the browser is JavaScript. What is an abstraction away from JavaScript? Give me an example.
Like what template React?
any library or framework that you use.
Libraries and frameworks. Okay. Well, what about what do we use Webpack for? Do you guys know that? This is the beginner. What about things like TypeScript? Right? Is TypeScript JavaScript?
It's
Yeah.
like a superset.
It's a superset. It is an abstraction of it though, because it adds to it. It adds a new paradigm, right?
It compiles down to JavaScript.
Yeah. What about like JSX or like any of this other stuff that we transpile at the beginning? Like all these are abstractions that this is a new word for me, that reify back down into JavaScript. And so as you go towards the concrete, it's called reification. That's a real word, unlike abstractification. So now we're actually gonna move into a couple paradigms. We're not gonna talk about specific languages necessarily, but these paradigms. The first one that we're gonna talk about is non-structured versus structured. Okay, non-structured, and these aren't like hard and fast rules. These are like general ideas that like might describe what these mean. But structured, there's sequence. You do this, then you do this, then you do this, then you do this. They had a lot of breaks, like go to. Not breaks, sorry, jumps. A break is considered a jump. Where you're like running the code, and then it's like all of a sudden you have to jump to this section of the code, right? And then it runs that code, and then here it jumps back over to this section, and then it jumps over to here. And so you create, like, one of the bad things is it created a bunch of spaghetti code. What you probably didn't realize was, I don't know if you've heard, but like goto is like a bad word in programming. Like you don't want to use goto. Although there have been some articles over the past year that like try and like convince people to use goto now. But break and continue. Like if you're inside of a loop or something and you use break and continue, those are actually similar constructs to goto. They're jumps that take you out of the flow of the natural flow, the sequential flow of the program. I have not been tracking my time, so hope you can. Hopefully I'm okay.
Maybe 5 to 8 more minutes.
Okay. No blocks or scope, so everything's kind of like in the global area, so it's hard to keep track of things. There are subroutines, which are like functions, but with multiple entry and exit points. And then we can compare that to structured. We add a couple things to the control structures. It's no longer just sequential. We have selections, which is like if statements. We have iteration, we have loops now. There's no jumps in the structured world. Blocks and scope has been introduced. Subroutines with single entry and exit points. Those are characteristics of structured paradigms. So now we're moving to procedural versus functional. And procedural and functional, the idea behind procedural would be kind of like what we think of as a JavaScript function. It's like a subroutine. It's like a set of instructions that we set aside. It's making the code modular so that we can reuse this piece whenever we want to through a function call. But the thing is that in JavaScript they're called functions, but they're really kind of like procedures that you can turn into a function if you want. These are some other names for them: subroutines, functions, procedures. We introduced the call stack, which is like you call this function, and then you call this function, and it has its own space on the stack. And then once that function's done, it drops back down to the previous level on the stack, and then it might call another one. Before I explain this one, I have to explain this one. Functional, there is one thing that makes something functional. There's one goal and one goal only, and that is referential transparency, which is a big, ugly set of words. It just means that the function can be taken out and replaced with the value that function produces without changing the functionality of the program, okay? So another way to look at it is the input, for any given input, it always returns the same value. This kind of goes back to the old like mathematical algebra way of like thinking of a function where if you have the parabola like this, it's a function. You remember the vertical line test? And the parabola like this is not a function. Why? Because it produces two values, right? So it might produce one, it might produce the other. That's not a function, okay? Referential transparency will always produce that one result given the same inputs. Okay, so a lot of times you'll see like, oh, this is functional programming because it has closure or higher order functions or recursion, whatever it is. Those do not define functional programming. Those support referential transparency. They enable referential transparency to happen. So you can have recursion, you can have closure, and you can have higher order functions that do not enforce this, and therefore it is not a functional programming, okay? So when somebody says this is functional programming because there's closure, no. That may or may not be true. You have to look and see if there's referential transparency. Imperative versus declarative. This is the how and the what, okay? So this describes the algorithm. This describes the steps, the instructions that you're going to take. Examples are the control structures that we talked about. Declarative is the what. It ignores the how. You just say, give me that, right? And you don't care how they do it. So examples of this are, libraries and APIs. If you add a dependency that you're just going to call whenever you need it, you don't really care. You probably should know how to implement it to make sure that you understand the API and stuff. But under the covers, you don't really care what's going on. It's declarative. All you care about is what it spits back to you. SQL, same thing. You declare what you want, and the database engine will take care of the rest. HTML, the browser will worry about it. You're just describing what you want. JSX, the same thing. So those are some programming paradigms. There's more. Asynchronous is another paradigm. I actually don't like the term synchronous because Synchronous to me makes it feel like it's all happening at the same time. Asynchronous is correct because it is getting back to the end of the line, right? It's like you kick off a callback and it's getting in line, right? Everything's happening not at the same time. But synchronous programming is still sequential, right? It still has to follow the sequence. So like synchronous to me means like everybody's moving at the same time together. So I don't like the word synchronous, but that's what it means. And synchronous in programming languages just means the opposite of asynchronous. Logic, Prolog is a programming language that's actually based off of higher order logic principles. What are they called? That's okay. GUIs. I mean, has anybody done Scratch?
Yeah.
Scratch is like what my kids program with Scratch. It's a bunch of, or Blockly. You move around a bunch of blocks that represent control structures and data that you can make a program out of. AI. I mean, someday maybe we're going to be talking to Alexa or Google and saying like, hey, this is the program I want. And it might be able to do that. So I don't know if you saw, but some of these are hard to differentiate from each other, especially like structured, procedural, imperative. They have a lot of common themes throughout them, but the way that I understand it is by understanding the pair of it. So when I think of imperative programming, when somebody says it's imperative, I think of declarative, and now I know what imperative means. When I think of procedural programming, I think of functional programming, now I know what procedural programming is. When I think of structured, I think of non-structured, now I know. So this is a basic, like one of the most basic React programs you can make. Okay, I'm sorry if it's incorrect. I kind of just like slapped it up here and didn't double check anything, and it wasn't in an IDE or anything. So, can somebody tell me some of the paradigms we're using here?
Declarative.
Declarative, where?
Get element by ID.
Okay, yeah, that's declarative. Yeah, you're just saying like, hey, I don't care how you do this, just go do it, right? That's right. That's declarative. Anything else? I think I skipped object-oriented, but that's okay. I don't know what happened with that. You guys know what that means. So this is object-oriented too because you're pulling off of the document. Like it's not. If you look at something, my point is it's not just like, okay, this is a functional program. No, there's probably pieces that are functional. There's probably pieces that are declarative. There's probably pieces that are a lot of different things. Oh, this isn't working either. So, and the other thing is going back. This is my last slide, by the way. Going back to the idea of having like something more abstract or more concrete, you can also like with some of these paradigms, it's not like absolute. Like this little component is declarative or it's not declarative. Because the truth is it might be more declarative than something else, or it might be less declarative than something else. It's a comparison. It's relative. An example would be the old like while loops. Right? I mean, I say old while loops. Like a while loop, right? Like you declare some variables, you tell it exactly what to do. It's very imperative. It feels very imperative. And then you go to like a for loop, and all of a sudden you kind of like it's like an abstraction off of the while loop, and you take like these values and you just kind of shove them in this parentheses. It's more declarative, right? So nobody would look at a for loop and say that's declarative. But it is more declarative than a while loop, right? But it's also less declarative than a for each, right? And you can get into like, is for each declarative? Is it functional? Well, it depends on how it implements it. It depends on how you're using it. So hopefully this just gives you kind of a little better idea of like maybe some of the definitions. They might be right, they might be wrong, I don't know. But that's what I got.